Recommendation or recommender systems are algorithms and tools designed to predict users' preferences and suggest items or choices based on their past behavior, preferences, and various other input factors. These systems are widely used in different applications, in particular on digital platforms, so you have almost certainly already interacted with many of them, even without your knowledge. They are used in e-commerce, music and video streaming, social media, news websites, travel and hospitality, online dating, job portals, and research. Recommender systems use a variety of techniques and algorithms to produce suggestions to users. At high level, these systems typically involve gathering data about users, processing this data to find patterns or structures, and then making predictions or recommendations based on these patterns. The most common approaches in recommender systems are collaborative and content-based filtering. The fundamental idea behind collaborative filtering is to make automatic predictions about a user's preferences based on the preferences of many users. It assumes that if two users agree on one issue, they will likely agree on another issue. This may or may not be true and may lead to problems, but more on that later. Similarly, if users have the same opinion about a particular item, then they will likely have similar opinions on different items. Coming from this, there are two primary types of collaborative filtering. One is user-based collaborative filtering. It identifies users that are similar to the targeted user based on their historical preferences. It will recommend items that similar users have liked, but the targeted user hasn't interacted with yet. On the other hand, item-based collaborative filtering measures the similarity between items based on users' interactions. For example, if user A and B both like items 1 and 2, then items 1 and 2 are considered similar. Content-based filtering uses the inherent properties of items and the profile of the user's preferences. Here, each item in the dataset is represented by a set of descriptors or features. For a movie, this can be actors, director, or genre, for example. Recommendations are made by comparing the user's profile with the features of items. The more the item matches the user's profile, the more likely it is to be recommended. Well, I hope this helps you finding the new recommended movie to watch tonight. The advantages of this approach are that it is more transparent than collaborative filtering. There is no cold start, meaning that the algorithm needs several data points before it can make any sensible recommendation, and there is no need for user interaction data. The challenges include the fact that it is limited to item content, meaning it's less likely to introduce users to entirely new categories. There is the risk of a filter bubble, meaning overly narrow recommendations. Extracting meaningful features from some types of content can be challenging and computationally expensive, and this approach does not account for the user preferences changing over time. Most recommender systems are actually using a combination of both types of filtering. For example, a video streaming platform may combine the information obtained from the videos that the user watches or from search history, which is collaborative filtering, and based on the content of the videos that the user has ranked highly, content-based filtering. Some other approaches include knowledge-based recommendations, using explicit knowledge about users and items. This is useful when the interaction is sparse. Association rule mining, by figuring out what the user wants to buy, if they're buying components to build something, and context awareness recommendation. For example, when expecting the first snow of the season, maybe buying a snow shovel is a good idea. Data used to train recommender systems can contain biases, which are then reinforced and amplified by the system. This leads to unfair or discriminatory recommendations. Scalability is also a problem with growing numbers of users and items, especially in real-time scenarios. Recommender systems may overly promote popular items, overshadowing niche items of comparable or better quality. Privacy concerns are always an issue when collecting and analyzing personal data. Luckily, GDPR and similar regulations are here to empower the consumers. Finally, we should be aware that the recommender systems work primarily for the content provider and not for the users. Thus, this system is more likely to prioritize the items the seller would like to sell and not necessarily the items that user needs. At the end of the unit, you will find several questions to test your knowledge. Here is one of the questions. Customers who bought X also bought Y is an example of item-based collaborative filtering, user-based collaborative filtering, content-based filtering, or user profiling. What do you think?